Well, welcome to 8.1. We're going to start with 3 rules today on exponents. Now, as you saw in class, we first start by talking about what if we have the same base number being multiplied. So here I have 3 being multiplied. And the first one has an exponent of 2 and the second one has an exponent of 4. What would happen with that? Well, the first thing is to make sure you understand what these things mean. Remember, exponents mean that you're multiplying. So if I look at 3 squared, what I'm saying is I have 3 times 3. And then if I look at 3 to the 4th power, what I'm saying is that I have 3 times itself 4 times. So I have the base number 3 4 times. Now here's the deal. This is really important. It's the same base number over and over and over again. And so we're multiplying them. See, if it was adding, it'd be totally different, but I'm multiplying every time. So really, if we look at the big picture of this, I've just got a whole bunch of 3's being multiplied, right? I have the first 2, and then I multiply again, because that's what the problem said I was doing, and then I have the last 4. And so if we don't color code it, it all just looks like I have a whole bunch of 3's being multiplied together. So then I can rewrite it as 3 to the, I have 1, 2, 3, 4, 5, 6 of them, so 3 to the 6th power. Right? And then if I try another one, so let's say my next one is, let's say 4 times 4 cubed. So by the way, this first 4, it doesn't have an exponent, right? This first 4 doesn't have an exponent. That just means there's one of them. I'm not telling you that there's more. There's just one of them. So we could put a 1 as an exponent if we wanted. And then it's a times, right? That says times, so we'll do a times. And then we have 4 cubed, so that means I've got 3 4's being multiplied. And if I take away the color coding, right, I've got all these 4's being multiplied, 4, and then times 4 times 4 times 4. And so really, I've just got 4 4's. And so we talked about this, no matter what your base number is, as long as you're taking that base number, and so let's just use an x because it could be anything. And if we have x to any number times x to another number, and as long as I have multiplication of the same exact base, I'm going to keep that base. I'm not changing that. Notice how I had 4's up here and it's still a 4 down here. Okay, I'm not changing them, I'm not multiplying the 4's together, all I'm doing is I'm rewriting it, and instead of writing all these x's, I'm just going to write the 1x, but then I have to say how many I have, and we've noticed already that it's going to be a plus b. Okay, so here's rule number 1. I would write that down in your notes, please. Okay, the second thing that we're going to look at is, what if we have a number raised to an exponent, and then we raise that to another exponent? So if we look at what the definition of an exponent means, is this exponent right here. So this exponent right here is telling me that I have 4 of these. So I'm going to write those out. So I have 3 squared times 3 squared times, that's a third one, and then a fourth one, right? And so what this is saying is I have 2 3's, and I have another 2 3's, and another 2 3's, and another 2 3's. So really, I have 3, 2, 4, 6, 8, 3 to the 8th power, right? Now I want you to notice, how many groups of 2 do I have? I have 4 groups, right, of 2. And that's no coincidence, because that told me I had 4 groups of 2. And if you remember, groups of means multiplication. So let's look at another example. Let's say I have x squared to the 5th power. Well, that means I have x squared how many times? According to my exponent, I have it 5 times, right? And so what's happening is I'm giving myself groups of 1, 2, 3, 4, 5. I have 5 groups of x squared, which means I have x to the 10th, right? I have x squared 5 times, so that gives me 10 x's. And so our second rule that you should write down in your notes is that if you have x to an exponent, and then you raise that to another exponent, by the way, x doesn't matter, it can be a number, then what you're going to do is you're still going to have the same base number of x, but you're going to take your exponents and you're going to multiply them together to give you your new value. So this is your rule number 2 that you should write down in your notes. And I have rule number 3, and that is if you have a multiplication inside of your bubble and you raise that to an exponent, what you're saying is you have this that many times, right? So you have 5x times 5x. Well, multiplication is commutative, so I can rearrange this. So I've got 5 times 5 times x. So really I have 5 squared times x squared. Right? If I did another one, so let's say I have 3p cubed. What I'm saying is I have 3p 3 times. This is all multiplication, so once again it's commutative. So I can move my 3's in the front and the p's in the back. And really what I have is I have 3 3's and 3 p's. Now the only reason it works out this way is because, once again, this is multiplication, and remember exponents, when we write it out, is more multiplication. So the only reason this works is because we have multiplication being multiplied, okay? And so really what's happening and what you can do is if you have an exponent on a bubble with multiplication, then you can put that exponent so that it's on both of them separately. Okay, so I have multiplication here. I can put this exponent on both of them separately. So now I have 3 cubed and p cubed. So let's look at that rule. The rule says if you have two things inside the parentheses being multiplied to an exponent, then you can apply that exponent to both of them separately and get your answer. So let's look at some examples so that you can see how these are going to be used. All right, let's start with, if we have 4 to the 5th times 4 cubed. Once again, I'm going to ask you that you write it out in your homework. We're going to rewrite the same base, so it's the same base the whole time. And now I'm saying that I had 5 and I have another 3, so that means I add them together. And yes, I expect to see that written down. And so you have 4 to the 8th. Okay, another example, I have negative 5 times negative 5 to the 3rd. Remember, if there is no exponent, then you can put a 1 there because you're saying you just have one of them. So I have this base, so I'm going to still have that base. And then I take my exponents and I add them. 1 plus 3. Remember, I want you to write that out. And so we have negative 5 to the 4th power. Now, what you should also do is get out your calculator and figure out what these are. I'm going to let you do that. Okay, another example. If I had 5 cubed squared, remember our rule is if we have an exponent raised to another exponent, we are going to multiply those. And so we get 5 to the 6th power. And once again, you should figure out what that is. Okay, another example. If we have 3 times 4 squared, that would give me, well, I have a multiplication, so I can apply that squared on both of them. So we got 3 squared times 4 squared. And you can figure those out separately and then multiply those out and figure out what your answer is. It gets a little bit more interesting. So what if you had 3xy to the 4th power? Well, here's the thing. This changed the rule a little bit because so far in the rule I've always showed you 2 things being multiplied, but here we have this, this, and this. They're all 3 being multiplied. Sometimes people look at this 3 as being stuck to the x, like they belong together and you can't separate them, but that's not true. So what's going on is it's 3 things being multiplied, so we're going to apply the 4 to all 3 things. All right, so we have 3 to the 4th, x to the 4th, and y to the 4th, all being multiplied. 3 to the 4th is 81, and then I can't simplify x to the 4th, and I can't simplify y to the 4th, so this would be my answer right here. Okay, another interesting one, and this will be my last example for this video, is if you have 3x squared and then we square that. So the first thing I see is that I have 2 things being multiplied, so I'm going to apply that to both of them. All right, so we've got 3 squared times, and then I'm going to put a bubble around the x squared and squared, because here's the thing, x already has an exponent, so I put a bubble just to show that they're separate. Otherwise, if I just wrote x squared squared, it's going to look like I have like 22 or something. Okay, then I do the next step, so 3 squared, I can do that, that's 9. And remember our next rule said if you have an exponent to another exponent, you multiply them, so 2 times 2 is 4. And so my answer is 9x to the 4th. All right, so that would be the end of that lesson. Go ahead and tomorrow during class we'll go over this assignment.